All right, here we go. Unit 3, Lesson 4. Unit 3 is all about similarity. Your featured athlete today is Deion Sanders. They used to call him Neon Deion. He was a two-sport athlete, kind of like Bo Jackson. He was a baseball player for the Braves, Atlanta Braves. And then he was a cornerback for the Atlanta Falcons. He was so fast. He's now the coach of University of Colorado Boulder. But back in the late 80s, early 90s, this is 1989 card. Anyway, he was a force on defense. He would also, I think, return punts and kickoffs. Yeah, Neon Deion, super fast, cool guy. He was pretty flashy. Liked attention, but awesome two-sport athlete. And he was on the Atlanta Braves with like the Sid Bream, Tom Glavine, Greg Maddux, John Smoltz, Braves. So he got on some good baseball teams. But anyway, Deion Sanders, current coach of University of Colorado Boulder. All right, here we go. Lesson 4 practice problems. Let me zoom in so we're good to go. Alrighty. We got multiple choice problem to start us off. No, sorry. Number 1. Here we go. I'm gonna zoom so we can like disregard this one for now. So we're just looking at number 1. Forget about this one for now. So angle ABC is taken by a dilation with center P and scale factor 3 to angle A prime, B prime, C prime. The measure of angle ABC is 21 degrees. What is the measure of angle A prime, B prime, C prime? So the concept here is that angles stay the same in dilations. So in a dilation, the angle stays the same, meaning corresponding angles so corresponding angles, not sides, but corresponding angles have the same measure. That's what you need to know. So you can pretty much disregard like this whole first sentence. I mean, sure, you need to know that A prime, B prime, C prime is the image and ABC is the pre-image. You need to know that for sure. You can easily tell that by the primes, but this is so easy. Because angles stay the same in dilations and corresponding angles have the same measure, you're just gonna simply say that angle A prime, B prime, C prime also equals 21 degrees. That's simple. So that's your final answer. And 1 down. Okay, number 2, here we go. Select all lines that could be the image of line M. Here's line M right here. By a dilation. So here we go, here's line M. I'm gonna use crayon just so we can visualize this. All right, so there's line M in red, right? So select all lines that could be the image of line M by a dilation. Here's the concept that you need. The concept is that when lines are dilated, they are taken to parallel lines. So when lines are dilated, they're taken to parallel lines. So basically, you gotta select all the lines that are parallel. Now, what's a good example of parallel? How about the 2 L's in all? The 2 L's in all are parallel. They are never going to intersect. So we're just looking for any lines that are parallel to M. So I'm just gonna say N and P for sure. And I believe that is it. So N and P. Now let's cancel some others out. L for sure, no, because they intersect right there. M, ooh, almost got me. M would work too, because say the center of dilation was actually on, say the center of dilation was actually on the line M. If we dilated it, it would be taken to itself. So M would work. Now let's look at O. There's an intersection point right there with M, so that's no good. So when lines are dilated, they're taken to parallel lines, or the same line if the center is on the line. Almost forgot to tell you about that. All right. So concepts: when lines are dilated, they're taken to parallel lines or the same line if the center is on the line. So MNP. All right, let me get some coffee. Okay, 2 down. Here we go. Claire, you want to toss this for me?
Sure.
Cool. Oh wait, I need it. Backside, sorry. Never mind. I'll talk to you in a couple minutes about that. Okay.
Can I open this?
No, don't open the Jerry
Dad,
Rice
it's
golf balls.
mine.
Uh-oh, Claire has joined us. All right, disregard Claire. She's going to interrupt. Get out of here. All right, go read a book or something. Go read some books.
I'm gonna steal you.
Okay, yeah, steal some colors. All right, here we go. Dilate line F. Here's line F. Get my trusty crayon for visual
Oh,
aid.
Dad,
Claire, I'm filming. It's not a conversation, okay?
Can I show my scribbly?
You're scribbly. Maybe at the end. How about that?
Yay.
All right. Try not to interrupt though, because it'll waste all these students' time. Okay? All right, so we got to dilate line F with the scale factor of 2. The image is line G, so this is the image. That means F is the pre-image. Right. Which labeled point could be the center of this dilation? Well, for sure, F goes to G, so C is out. Because as we know, if a point, or if the center is on the line is taken to the same line, right? So C is for sure out. So if you want to start ruling them out, you can. Let's look at A. If this was the pre-image, line F, the starting line, and A was the center of dilation, C prime would be like over here somewhere, right? And then let's say like this one would be like over here somewhere. So we would have a line like kind of like this if A was the center. Be taken to a parallel line. And I'll just do it for you real quick. If A were the center, that's about 3.95, so it'd be like right here. And then let's do one more. Okay, that's 3, 6. So if A were the center, the line would be like this. But A is definitely out. Let's look at B. So if B were the center, watch this. I'm just measuring from B to C. If B were the center, we're going 1.7? So it'd go 3.4. B prime would be like right here. Let's try one more. We'll just go from here. Here, 1.5 times 3. So if B were the center, would be like this. So you know B's out too. This would be if B were the center, if A were the center. So B's out. So you're only left with one, which is D, and I'll show you why. Let's check D to C. D to C is 2.4 and 4.8. There you go. So this would be C prime, right? So DC prime, twice as big as DC. You see that? DC prime, twice as big as DC. Let's try one more. Let's go DB. DB is 3.2, so it should be 1.6, and it sure is. So this point right here is half dB, so I'm okay with just going with D. You've pretty much shown it, and that's how you work on these. Now this is the line if B, this is the line if A. If it were C, it would be the same line in red crayon, and our answer is D on that one. Okay, let's, I'm trying to explain these so you don't just like wonder why, in case you're wondering what I'm doing. All right, number 4, quadrilateral A prime, B prime, C prime, E prime is the image of quadrilateral A, B, C, E. Quadrilateral is 4-sided polygon. After a dilation centered at F. So we're going from FA down to FA prime. We're going from FC down to FC prime. We're going from FE down to FE prime. We're going to FB down to FB prime. So I know it's getting smaller, which means that the scale factor is less than 1. So I know that automatically, right? The easiest way to do these is to set, here's like the formula that you can use every time. You can just go AB over A prime, B prime, and that's gonna equal BC over B prime, C prime, which is gonna equal CE over C prime, E prime, which will also equal EA over E prime, A prime. Now, if you're wondering what that means, let's just do an example. AB is 3 over A prime, B prime, 1.5. BC is 6 over B prime, C prime, which is 3. Geez, I'm messing everything up. I'm so sorry. Gotta flip them. So here we go. We're gonna go A prime, B prime over AB equals B prime, C prime over BC, which equals C prime, E prime over CE, which equals E prime, A prime over EA. Let's try this again. All right, because I know it's getting smaller. All right, so here we go. Keep it up. A prime, B prime is 1.5. AB is 3. B prime, C prime is 3. BC is 6. C prime, E prime is 2.5. CE is 5. And E prime, A prime, they didn't give it to us, or EA. So what is this? 1.5 over 3 is the same as 1 over 2. 3 over 6 is the same as 1 over 2. 2.5 over 5 is the same as 1 over 2. That's our scale factor. Our scale factor is 1/2. So put the primes over the original, and that's how you'll figure it out. So put the primes over the original, or the image over the pre-image. That's how you can find it. So easy. Image divided by pre-image. Just find corresponding sides. So it's corresponding sides. Image over pre-image. That's how you find it. That'll work every time. Okay. 3 and 4. Claire, can you toss this one for me? Right in there. Thank you. All right, numero 5. Polygon has a perimeter of 18 units. So P equals 18. It's dilated with the scale factor of 3/2. So SF equals 3/2. What's the perimeter of its image? Well, perimeter is side lengths. So much like you can go with an individual side times the scale factor, you can also go with the perimeter times the scale factor. So we're just going to go P times SF equals P prime. This is original perimeter times your scale factor equals new perimeter. How easy is that? Original perimeter times your scale factor equals your new perimeter. So original perimeter 18 times your scale factor 3/2 equals P prime, which is what you're going to solve for. Now you can envision this as a 1. Multiply the tops, multiply the bottoms. 18 times 3 is 54. 1 times 2 is 2. That's your new perimeter. 54 divided by 2 is 27, is your new perimeter. That's your final answer. Then you just look for it, and there it is. Easy. All right, number 6, solve the equation. This is cross multiplication. So simple. Now, I don't want to confuse you, but you can only use cross multiplication if there's an equal sign, and there is an equal sign. See right here, when we multiplied fractions, you got to multiply the tops and then put them over the bottoms. So like 54/2. So when you're multiplying fractions, you got to go tops over bottoms. But when you got an equal sign in between two fractions, then you can just cross multiply, which is like the easiest thing in the book. So 4x equals 70, x equals 70 divided by 4. That simplifies because we can take out a 2, so 35/2. So x equals 35/2. You could also say 17.5. And then I'll show you 4/7 equals 10/17.5. In both of these, we multiplied by 2.5. So it's like scaled up, right? Okay, anyway, here are some measurements for triangle ABC and triangle XYZ. All right, angle CAB and ZXY are both 30 degrees. All right, so AC and XZ are 3 units, so I'm just gonna work down here and build these. So AC and XZ, 3 units. Build a couple triangles, y'all. So that's AC. And XZ. I'm just using the centimeters on my protractor to figure this out. I haven't seen this problem. I think I know where they're going. So AC, XZ is 3. Okay. CAB and ZXY are both 30. Okay, so check this out. So you go center on center, line on the line, mark a 30. Okay, center on center, line on line, mark a 30. Okay, so we know that CAB, wherever it lands, and ZXY, I think they said, have 30-degree angles. So we got 30 degrees, 30 degrees. Okay? almost there. So we have this and this. Like B is going to be up here somewhere, right? And then CB and ZY both measure 2 units. All right. How can we do this? CB and ZY both measure 2 units. All right, here we go. So, hang on. Here, I'm gonna show you something, little trick. This is a tough problem. You're basically proving why side angle or backwards, you know what. Don't want to make assumptions, right? Anyway, you're essentially proving why side angle is not enough. So watch this. This circle represents all the spots that are 2 units away from C. I know it's getting a little crazy here, but ZY also is 2, so we're just going to put our center of our compass on Z. Do the same thing, and I'm going to show you why side angle is not enough. It's pretty cool. Alright, so check it out. Watch this. Spin this line a little bit. Point to point. You're going to see 2 intersection points with this circle. Or in other words, 2 options. Can't have 2 options if they're congruent. You can only have 1. But anyway, I'm talking to myself here. But watch this. For this one, we're going to use this point for B. Which, as you know, is 2 because I measured 2 centimeters and I created that triangle that way. And then for this one, we're going to use ZXY. I'm going to show you something pretty cool. Alright, now I just need some colors that actually work. Nope. See if green works. Yes, green works. See if pink works. Nope. Nope. Yeah, I need new colors. Alright, orange works. So check this out. There's an orange one. Has a 30-degree angle, right? It's got a 30-degree angle. It's got a 3 and it's got a 2. Remember? Circle, right? Let's look at the green one. Green one's got a 30-degree angle. A 3 and a 2. Side angle not included. Side angle not included. This is the 30. Therefore, side angle is not enough to prove triangle congruence. That's why I never taught you SSA. I taught you ASA, SAS, and SSS. These are all good. But SSA is not, and here's a good example. So let's go back to the question. Andre thinks these triangles must be congruent. All right. Claire says she knows they might not be congruent. Hey, Claire, you're in the curriculum. What do you know? She's standing right in front of me. Say hi. Throw a hand underneath.
Hi.
Okay. Get out of here. Claire says she knows they might not be congruent. Construct two circle triangles with the given measurements that aren't congruent. So I did that. So we're good. Explain why the triangles with three congruent parts aren't necessarily congruent. Because these two triangles are not congruent because they are not the same shape. And I provided only one example to disprove side-side angle, and that's all you need. All you need is one example to disprove something. So these two triangles are not congruent because they're not the same shape. And I just provided an example to disprove it. Whew, that was tough. If you can do this problem, like, you're stoked. You're getting it. You just disprove side-side angle. That's tough to do. All right, that is, can you toss this for me, Claire? And that is Unit 3, Lesson 4.